Hi, this is Year 12 Pure, Chapter 10, Lesson 6, and today we're going to be solving trigonometric equations with identities. The identities that we're going to be using are tan theta equals sine theta over cos theta, as well as using sine squared theta plus cos squared theta is equal to 1. Also, you'll need to know how to solve basic trigonometric equations, more difficult trigonometric equations, and those are in the previous two lessons of video, so make sure you're watching them in the correct order. Right, let's get cracking. So in this question we've got solve for theta in the interval where, it should say theta in there, shouldn't it, where theta is between 0 and 360 for each of these equations. Now these aren't too bad, they're not too scary. We'll have a look at question A first. Now in this case what you've got is something that looks a bit like a quadratic, just looks a bit like one. You've got 2 of something squared, take away some amount of something, take away some constant. And so we can factorise this. Now if you struggle to factorise this when you're looking at it with cos, you can just call it 2x squared minus x minus 1, factorise it and then put cos back in. If you don't, then you should be absolutely fine anyway. So we're looking for two numbers that will multiply to make -2. That's -1 times 2 is -2, and also will add to make -1. Now those numbers will be -2 and 1. And what that does is rewrite the negative cos theta, and we'll get -2 cos theta plus cos theta plus 1 is equal to 0. So you can see that we've formed something that's worth the same but just looks a little bit different. We'll factorise each side and we'll get 2 cos theta lots of cos theta minus 1, and we'll get, oh sorry, this was minus 1 up at the top there, and we'll get plus 1 lots of cos theta minus 1. And so our brackets will be 2 cos theta plus 1 and cos theta minus 1. Alright, so we'll get two solutions. One will be the case, two sets of solutions. One will be the case where we've got 2 cos theta plus 1 equals 0, so that's case 1, which is 2 cos theta plus 1 equals 0. So cos theta will equal -1/2, and theta will equal inverse cos of -1/2. Okay, pop that into your calculator. So we've got shift cos -0.5, close the brackets, and we end up with 120 degrees. Okay, you need to cast as well. So we've got 120, which is there. So that would be 60. So there's 120. We've got C, A, S, and T, and we've got another 60 there. Okay, so that's going to be 180 plus 60. So we've got 120, and then we've got 180 plus 60. So we've got theta equals 120, and 180 plus 60 is 240. Okay, so those are two of our solutions. The other bit, we've got case 2. Now case 2 is cos theta minus 1 equals 0. So cos theta equals 1. So theta equals inverse cos of 1. Okay, put that into your calculator. Inverse cos of 1, which is 0. Okay, that's because if you're thinking about the wave here, cos wave starts like that. There's 90, 180, 270, 360. So it equals 1 when theta equals exactly 0, but also when theta equals 360. 0, 360. And if you're thinking about that in terms of cast, it's basically exactly there, isn't it? Okay, and so that would be 0 and all the way around 360. So you get values for question A, which are theta is equal to 120, 240, 0 and 360. Degrees, degrees, degrees and degrees. Okay, hopefully that's okay. Moving on to question B, we've got sine squared of theta minus 30 equals 1/2. Now what we're going to do with question B is we're going to square root, so we'll get sine of theta minus 30 is equal to root of 1/2. But when you square root, you need to consider both the positive and the negative versions. So straight away we get to two different cases. We get case 1, which is sine of theta minus 30 is equal to positive root 1/2. And then we get case 2, which is sine of theta minus 30 is equal to negative root 1/2. Okay, so we'll solve them each individually. If you're dealing with theta minus 30, if this was theta, well, theta minus 30 would be negative 30 up to 330. So we need to find the solutions that land in there. All right, so let's find out what we've got. So we've got theta minus 30 is going to equal inverse sine of root of 1/2. Okay, and so theta minus 30 will equal, let's find out. We've got inverse sine of root 0.5, which comes out as 45. Whoops, I've written a quarter there. Comes out as 45. So we'll cast C, A, S and T. We've got 45 there as well. We need to go up to 330, so there won't be another answer, and so we'll get 180 take away 45, which is 135. Now if theta minus 30 is equal to each of these, then that means that theta will equal to 75 and 165. Okay, so those are the values generated by case 1. Case 2, probably a little bit more tricky. You've got theta minus 30 is equal to inverse sine of negative root 1/2. Okay, so let's take a look at what that looks like. So we've got inverse sine of negative root 1/2, which comes out as negative 45. So we get theta minus 30 is equal to negative 45 degrees, which falls outside of our domain here. Okay, negative 45 will be down like that. 45 C, A, S and T, and so we'll want this here, which is 45, so that's 180 plus 45 if we're carrying around like that. 180 plus 45 is 225, and 360 subtract 45 would be 315, and there aren't going to be any more that fit in that domain there, and we don't need that one. Now we're going to add on the 30, so theta equals 255 and 345, and so in this case theta equals 75 degrees, 165 degrees, 255 degrees and 345 degrees. Nothing too scary. A good way to check that is to substitute some of those into here, and you should be absolutely fine. Alright, we haven't done any rounding, and so they should work out exactly. Right, moving on. This question here says find the values of x in the interval blah 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 satisfying the equation 2 cos squared x plus 9 sine x equals 3 sine squared x. Now looking at that, the most eye-catching thing is the cos squared and the sine squared. We know that you can't have both of those. We're going to need to get just to have sine or just to have cos. The 9 sine x tells you that you need sine throughout, because you can't do much else with sine x and you can't do much with cos x. So if you've got sine squared x plus cos squared x plus 5 cos x, it needs to be cos x's that you aim for. Okay, it's this that tells you what you're aiming for, and it's this that tells you you can do something. So cos squared x is 1 minus sine squared x plus 9 sine x minus 3 sine squared x equals 0. Get everything to be on one side. Remember, if we're going to be forming a quadratic, which is what's happening here, you cannot do anything with the quadratic until it equals 0. Next you get 2 minus 2 sine squared x plus 9 sine x minus 3 sine squared x. That will be negative 5 sine squared x plus 9 sine x plus 2 equals 0. And because I really don't like having a negative there, I'm going to change every single sign. I'm going to multiply through by negative 1. No great reason, it's just my personal preference. I don't like that negative being there. Okay, so we get this. We need to now factorise, so we need two numbers that will multiply to make negative 10 and add to make negative 9, and they are negative 10 and 1. 5 sine squared x minus 10 sine x plus sine x minus 2 equals 0. Factorise both sides and you'll get 5 sine x, lots of sine x minus 2 plus 1, lots of sine x minus 2. And so our brackets are 5 sine x plus 1, lots of sine x minus 2 equals 0. Alright, so we've got two brackets, two different brackets, and so we've got two cases. We've got case 1, which is 5 sine x plus 1 equals 0. So sine of x equals negative 1/5. X equals inverse sine of negative 0.2. Okay, so we'll find out what that is. Get inverse sine of negative 0.2, which is negative 11.54. Negative 11.54. And we just need to find out the other points where this works. So we've got negative 11.54, C, A, S, and T. Sine is negative in there, so we need the other position where sine is negative, which happens to be here. That's 11.54, and so we can go back, not quite 180. 180 take away 11.54 will be 169.46. So we'll be going back that far, negative 169.46. So that's going back to negative 180. Going forward to positive 180, nothing. There's no solutions generated there. All right. And case 2 is where sine of x minus 2 equals 0. So sine of x equals 2. No solutions generated. If you try tapping that into your calculator, you can. Oops. If you try tapping that into your calculator will give you an error. There are no solutions generated. Sorry, I've switched to red by accident there as well now. And the reason that no solutions are generated is because the maximum for sine as a wave is 1, the minimum is negative 1. Okay, there's no value of x that you can plug in to make sine of that value equal to 2. It's impossible. Okay, sine starts off like that, goes like that. Okay, it will never be up as high as 2, so no solution generated. Your final answer will be that x equals negative 11.54 and negative 169.46. Alright, so here's an exam question. This is from January 2010 and it was from a C2 paper, so this is old spec. It's pretty easy. Give it a crack. Right, so hopefully you've had time to try it out. You should have paused the video if you haven't. Let's take a look. So show that this equation can look like this quadratic. Now this show that question is really nice because if you can't do part A, you can still have a good old go at part B. So we've got 5 sine of x equals 1 plus 2 lots of 1 minus sine squared x. So 5 sine of x will equal 1 plus 2 minus 2 sine squared x. So we'll get 2 sine squared x plus 5 sine x minus 3 equals 0. We need two numbers that will multiply. Oh yeah, I've got what I was asking for up there. We need two numbers once we try to solve this that will multiply to negative 6 and add to 5. Okay, and those will be 6 and negative 1. So we'll have 2 sine squared x plus 6 sine x minus sine x minus 3 equals 0. We'll factorise each side. We'll get 2 sine x, lots of sine x plus 3 minus 1, lots of sine x plus 3 equals 0. And your brackets come out as this. 2 sine x minus 1 lots of sine x plus 3. So we'll get two cases. Case 1 is where 2 sine x minus 1 equals 0. So 2 sine x equals 1. So sine x equals a half. X equals inverse sine 0.5 or a half. So we'll get inverse sine of 0.5 is 30. And then we'll cast. C, A, S, and T, 30, and so that'll be 150. Case 2, sine of x would need to equal negative 3. No solutions generated. Okay, just doesn't happen. It's outside of the boundaries of the wave, and so your final answers would be x equals 30 and x equals 150. Alright, here's another exam question. This one is from the A-level sample assessment material, so this is new spec. It's a bit more difficult, new spec questions tend to be. So have a little look at it and then we'll get cracking. So this question, it's asking for you to solve this thing that looks almost like a quadratic. It's still not quite just yet. Once we've got it to be a quadratic, we're going to be solving it, giving you answers to 2 decimal places. Once we've got it to look like a quadratic, the likelihood is that we're going to be able to factorise it. We'll get 2 cases, and we'll give all our answers to 2 decimal places. After that, we've got this thing to sort out. So we've got 3 sine squared x plus sine x plus 8 equals 9 lots of 1 minus sine squared x. So we'll get 3 sine squared x plus sine x plus 8 equals 9 minus 9 sine squared x. Move your negative 9 sine squared x, which will be 12 sine squared x plus sine x, and we'll have negative 1 equals 0. So we need 2 numbers that will multiply to make negative 12 and add to make 1. Now those numbers will be 4 and negative 3. And so we'll get 12 sine squared x plus 4 sine x minus 3 sine x minus 1 equals 0. Factorise each side. You'll end up with 4 sine x, lots of 3 sine x plus 1, and minus 1, lots of 3 sine x plus 1 equals 0, and here's your brackets. Okay, now we've got 2 cases. We've got case 1. You have to use this space down here. So we've got case 1, which is 4 sine x minus 1 equals 0. That means that sine of x must equal 1/4. X equals inverse sine of 1/4. Okay, so let's take a look at that. Inverse sine of 1/4. We've got inverse sine 0.25, which is 14.477. Okay, 14.478 even, pardon me. 0.48, there we go. Because we wanted 2 decimal places, you see, so we go for that, 14.48. That's C, A, S, and T. We'll get 14.48 here as well, 14.48. Now 180 take away 14.48, 180 take away 14.48 comes out as 165.52. So we get 2 values out of this, which is 14.48 and 165.52. That's going round to positive 180. Don't need to go any further than that. Going round to negative 180 won't produce any solutions. It's likely that you'll probably get some solutions out of this one. Alright, so case 2. We've got 3 sine x plus 1 equals 0, and so therefore sine of x is equal to negative 1/3. X is equal to inverse sine of negative 1/3. And so we'll find out a value for x now. So we use inverse sine of negative 1 over 3, which is negative 19.47. Okay, C, A, S and T. So we'll have this one here, 19.47, which means that we're trying to go around to negative 180, but we're not quite getting there. We're 19.47 short. So we've got 180 subtract 19.47, which comes out as 160.53, but that's negative 160.53, negative 160.53. Okay, so you end up with all of those solutions. Those are your answers for part A. Part A is all of these. Okay, so x equals negative 160.53, negative 19.47, 14.48, and 165.52. Alright, for part B, it says, hence, find the smallest possible solution of the equation, blah, blah, blah. Now that blah, blah, blah is exactly the same as the question up at the top, except x has been replaced with 2 theta minus 30. Now, what that means is that we're trying to solve, imagine we swap this x for 2 theta minus 30. So we'll have 2 theta minus 30 is equal to negative 160.53, negative 19.47, 14.48, and 165.52. Okay, 165.52. And what it's after is what's the smallest positive. Now, we're going to add on 30 onto everything, and you'll see that this is the most useful one, because when you add 30 onto this, you're going to end up with something that's positive. So 2 theta will equal, well, we've got 30 minus 19.47, which comes out as 10.53. And then we can divide through by 2 to get 5.27. That'll round to. Alright, so there's your answer for question B as well. Alright, thanks very much for watching. Hopefully it helped. Good luck.